In this video I'm going to look at the conjugate root theorem. So what it says is, if there's a complex number that is a root of an equation, well then the conjugate of that complex number is also a root. So for example, if the complex number 2 plus I is a root of this equation z squared minus 4z plus 5, well then 2 minus I is also a root. Where did I get 2 minus I from? Well, it's the conjugate of 2 plus I. So what do I mean by a root? Well, I mean that if I sub this complex number in for z here and here and work it out, I should get 0, right, if it's a root. Let's try it. So we're going to sub in this number, 2 plus I, square it, minus 4, 2 plus I plus 5 equals 0. When we square that, then we will get 4 minus 4I plus I squared minus 8 minus 4I plus 5 equals 0. That's 4 minus 4I minus 1, because I squared is minus 1, minus 8 minus 4I plus 5 equals 0, and well, the 4i's cancel, and we have 4 minus 8 is minus 4, and then minus 1 is minus 5, and minus 5 plus 5 is 0, so 0 equals 0. So we're after proving that is a root. By default then, we know that its conjugate to minus I is also a root. Okay, so just a few, I suppose one thing to know. If we were given the roots of an equation and we were asked to find the equation, so for example, here's a root, minus 1 plus I. We're told that that is the root of an equation. We're asked to find the other root, and then hence find the equation. Okay, well, first thing, here's one root. We're given that. Second root, minus 1 minus I. Why? Because it's the conjugate of the first root. And now, how do I find the equation? Well, we need to know this off. Okay, just need to know this off by heart. We say z minus the sum of the roots. Okay. Okay, so the sum of the roots is minus 1 plus I plus minus 1 minus I, and that gives us minus 2. So the sum of the roots is minus 2. So it's minus 2z plus the product of the roots. So I'll do that over here. The product means multiply. So it's minus 1 plus I minus 1 minus I. We multiply that out, we get 1 minus I plus I minus I squared, which is 1 plus 1, which equals 2, equals 0. So it's z minus minus 2 is plus 2, z plus 2 equals 0. So there's the equation. Okay, we just have to know this. Next question. If 1 plus 5i is a root of the equation az squared plus bz plus c equals 0, where a, b and c are elements of R, which means they're real numbers, find the values of a, b and c. Okay, well, we're given one root. Here it is. We know the other root then by default. It's 1 minus 5i, the conjugate of it. Now, it's to find the equation, it's z squared minus the sum of the roots plus product of the roots equals 0. Okay, so z squared equals the sum of the roots. Let's do it over here. 1 plus 5i plus 1 minus 5i, and that is 2. Okay, so it's minus 2z, and then plus the product of the root. So I'll do it down here. 1 plus 5i, 1 minus 5i, and we get 1 by 1 is 1, plus 5i plus 5i minus 25i squared, which is 1 plus 25, which is 26, plus 26 equals 0. So there is the equation. Okay, so now that I have the equation, which is here, I can easily find out what A, B, and C are. A, B, and C. So A equals 1 because it's an invisible 1 in front of the Z. B equals minus 2 here. And C equals 26. So there we go. Okay, next question. It says, given that Z equals 2 plus I is a root of this equation, show that the conjugate is also a root. Okay, well, to show that this is a root of the equation, we sub 2 plus I in for Z and see it as a given 0. We actually did that up here, and we noticed that this question, and we noticed that it did give us 0. Likewise then, if we sub the conjugate in, so 2 minus I, if we sub that in for Z, so Z squared minus 4Z plus 5 equals 0. If we sub that in, 2 minus I to be squared minus 4, 2 minus I plus 5 equals 0. If we work that out, we will see that it gives us 0 equals 0. Okay, last question then. Given that complex number 1 plus 2i is a root of this, okay, so they're telling us that it is a root, show that its conjugate is also a root. Okay, I'll do that first, and then hence find the third root, because this is a cubic equation, because we have 3 there, so it's going to have 3 roots, not 2. The ones we entered up here, they were quadratic equations, so they would have 2 roots. This one here has 3. Right, first thing, well, we're going to show that the conjugate of Z1 is 1 minus 2i, is a root of this. Okay. So we're going to put this in for Z. So let's write out the equation. Okay, so the first one, 1 plus 2i cubed minus 1 plus 2i squared plus 3, 1 plus 2i plus 5 equals 0. Okay. Sorry, this is minus 2i. Minus 2i. Okay. First thing I'm going to do is going to find out what this is. So it's 1 plus 1 minus 2i, 1 minus 2i, 1 minus 2i. I'll find out what this is first. Okay. If I square it out, I will get minus 3 minus 4i. If I was to multiply that then by the minus 1 minus 2i again, I will get minus 11 plus 2i. Okay, so this is minus 11 plus 2i minus, and we're already after squaring out this up here in this part, and I got this answer. So I'll just write that in. And minus 3 minus 4i. And then I have plus 3 minus 6i plus 5 equals 0. Just taking everything out of the brackets, I have minus 11 plus 2i plus 3 plus 4i plus 3 minus 6i plus 5 equals 0. And if I was to simplify all that, I would get 0 equals 0. So yes, that is a root. And then it says, hence, find the third root. Okay. Well, here's how I find this. I'm going to write out the roots I know. 1 plus 2i and 1 minus 2i. I know their roots. I don't know the third root. However, if I use these to get a quadratic expression, and then if I divide that quadratic expression into this cubic expression, my answer will be the third root. So here's what I'll do. First of all, I'm going to get a quadratic expression from these. How do I get the quadratic expression from these? Well, I go back up to this. Remember, z squared minus the sum of the roots, z plus the product of the roots. So we'll use these to get a quadratic expression. So z squared minus the sum of the roots will give us 1z plus the product of the roots. I think I multiplied them out already. I did. No, actually I didn't. I didn't have to be careful. 1 plus 2i, 1 minus 2i, and I'll get 1 minus 2i plus 2i minus 4i squared, which is 1 plus 4, which is 5, equals 0. So that will give us z squared minus z plus 5 equals 0. Actually, sorry, I made a mistake there. Really sorry now. The sum of these roots isn't 1, it's 2. I'll just do it out here. 1 plus 2i plus 1 minus 2i. They cancel. 1 plus 1 is 2, not 1. Okay, so it's actually 2z. So there's my quadratic. Now all I have to do is divide that quadratic into the cubic. So z squared minus 2z plus 5 into the cubic, which was z cubed minus z squared plus 3z plus 5. And this is just the usual algebraic division. So I asked myself, what do I have to multiply z squared by to get z cubed? And my answer is z. And then I multiply all of this by z. So I get z cubed minus 2 z squared plus 5z. And then I take away, and I end up getting, these cancel, I end up getting z squared minus 2z. I then bring down the 5, and plus 5. I ask myself again, what do I have to multiply this by to get to this? The answer is 1. So plus 1. And I get z squared minus 2z plus 5. And I take away, and I get 0. So my answer here then is z plus 0. So to find out what z is, I will just say z, I'll use my stabilizers, take away 1 from here, take away 1 from here, and get z equals 1. So, 3 roots, z equals 1 plus 2i, 1 minus 2i, and this one here, 1. And the magic is if I multiply it, sorry, not multiply, but if I put these, any one of these in for z in this equation, I would get out 0. Okay, so that's it guys, thanks.